Hi, and thank you very much for reviewing this work. This is Diego Souza here, and this is my final project for CSCA 5642 Introduction to Deep Learning with University of Colorado Boulder. And the title of this work is Synthetic Brand Generation with Ensemble Methods. As my peer reviewer, you have access to my GitHub repository. You will have access to this PDF, the PDF version of this presentation, and to the Jupyter notebook that I use to run this experiment. Actually, I run in Google Colab, so it's a Colab notebook. So the idea behind this project is to utilize the deep learning techniques that we learned during the course, and in my case, especially the generative um, part of it, because the objective here is to augment the original data set that I have. So this data set is a continuation of my work on supervised and on unsupervised learning, and it is a environmental, social, and governance data set, and we have information for the companies and for their brands. Please don't feel overwhelmed with all this information. You can look at the appendix, you can pause the presentation at any moment, and you can look at the files on my repository or the notebook. Moving forward, before digging into code and starting with EDA, I would like to give you a brief introduction on what I'm calling ensembles here. The ensemble methods. So the ensemble is where, as we learned, a combination of multiple methods. We have two ensembles. One is for generating the tabular information. It contains the conditional uh, GAN here, the conditional tabular GAN, the tabular autoencoder, variational autoencoder, and the statistical model, Gaussian copula. So this is the first ensemble. I'm calling it tabular ensemble. The second one is the large language model ensemble, and it contains, in my experimentation here, GPT-2 and Google T5. So from the bottom up, the LLM ensemble will be responsible for generating the brand name only. So from the 77 columns that we have in the dataset, these LLM ensemble will only generating the brand name. The tabular one will be responsible for generating all the rest of the 76 columns that we need to. Moving forward, in the graphic view, we have an overview of the pipeline. Nothing super, uh, mm, nothing super new, nothing anything that you don't actually know. We have the input data pre-processed here. The tabular ensemble does its job, so each of the models will emit a 76 a set of 76 columns, and then the sum ensemble weighting average happening here. This is the detail of what's happening. So each of the models have a weight, and this weight is decided on the voting for the average, for the weighted average. Second step is going to be the brand name generation. So the large language model ensemble does its work here. So GPT-2 emits one brand name, and T5 emits one. There's some voting happening here. The result is generation of synthetic brands with the 76 other columns. I run some quality evaluation. It's important to notice that I'm not very concerned about the KS test and the correlation. Of course, I want to keep some correlation, and I want to have something passing on KS test, especially the company name. I don't want to create new company names, and I want to preserve some of the rankings. You're gonna see at the development of this work here that I was able to preserve that, but I want to have some variation. Uh, One of the reasons to use a variation autoencoder is to, and the addition of noise that I put as well, is to keep some variety in the dataset. Forward, exploratory data analysis. I clean the data, I handle all the missing values, I encode all categorical variables. I had to pay special attention to the binary columns. It was a little challenging because the first ensemble kept on generating columns other than binary, so I had to do an extra work on that. Next is the hyperparameter tuning, and while I was developing this work, I stumbled upon this Optuna library. It's very useful. If you don't know that yet, I recommend you to go and take a look. It can save you many hours. It's very straightforward. It has a lot of parameters. For example, there's a timeout. For example, you can establish, okay, keep on going the hyperparameter tuning for 1 hour, and after that, decide what's the best one and go with it. So you can limit, especially if you have limited time on, in my case, Google Colab. Um, that was especially interesting to use. Have some visualizations here, and from the visualizations, we see that the 10th trial was the best one, and therefore we took the best parameters. And in this case, the best parameters that I trained was the number of epics on the generative adversarial network, the autoencoder, the batch size, and the shapes of the layers for embedding, for the generator, and for the discrimination of the CT GAN. Forward, now I started training the tabular ensemble, and the way I used to do stuff is I put on separate files and I create classes for that. Please feel free to go and take a look on what I did if you want to take deep in the code, and you see everything is implemented there, um, very organized way. Next step is to fine tune the large language models, right, which is sort of training, right? Um, Again, I did in a separate file, and here's just a snippet of what I did with that. Here I utilize Hugging Face. It's a Transformers service. It's very interesting. The other one that if you don't know that yet, go for it and learn it. It's actually very useful in production, like in the real world outside of the academic um, world. Right. So after fine tuning, I asked the model to generate three names for these three companies here. You see, quality is not very good because here we have a leakage, right? So a competitor leakage here, and as well here. The third one is, a little bit better for Nestle, um, and then from Mars Incorporated. In any case, we're not evaluating it right now. This is just a sample of the generated brand, proving that the large language models were able to generate brand names. And now the next step is to actually generate for the number of companies that needed to generate the brands. Here I limited the number of brands, the companies to be to have the brands in 150 because of my time constraints. But the logic in the program is to generate for every single one that needs didn't meet a threshold that I established. Um, so if you're running this experiment on your machine or in your Google Colab, you can just go and modify my code and remove the 150, and it will run for whatever number of companies that is needed. Now, the final step is to evaluate um, the synthetic data that was generated. So I'm evaluating pretty much the tabular data in this next slides. And I'm executing some PCA and TSNE for visualizations. So there's always a trade-off in machine learning, and here the trade-off for me was between variance and fidelity. I wanted to keep some fidelity, but I I prefer to have more variance. So I'm prioritizing variances here in order to have a more diverse data set. Um, so based on this chart here, only a handful of properties or features here are passing. The ones that I'm more concerned about, the in industry ranking and the company name, they're all green, so we are good with that. Um, I am less concerned about the this guy here, market cap, number of employees. I was a little concerned about these indexes, I mean these factors here, the greenwash factors, but I'm okay with the results for now. Let's move forward. Here again, we have a distribution comparison. Again, the two one that I was very concerned about, the industry rank, because I needed to compare the industry with the brand on my unsupervised learning process. So I was concerned about this guy and the company. So they're all passing, and the distribution looks very like the real one. Um, Same here, but now it's a QQ plot showing the hyperplane. So we are almost, for example, for a company here, we are almost in the range of perfect match. And for the in industry ranking, I have some variance here. Very good. I applied, as I said, dimensionality reduction here. I'm using PC1 and 2. And they are able to explain a good deal of the variance. And we see by the plots of the synthetic data kind of lines up with what we expect the real data to line up in the PCA. And for the TS and E, as well, we'll see that the orange ones are well distributed here. A little skewed to the right hand side, but not a big deal here. We don't have no uh, outliers per se. All right, so next is a statistical comparison. And now, statistically comparing, you have a little better graphic here, right? So some of the ranks are passing. We're comparing the standard deviation. The greenwashing factors are almost all in an okay state here. And the ones that I'm not concerned about, for example, the market cap billion, they can extrapolate. I'm not very concerned about that one. So this is a good sign for the experiment that I'm running here. Now, as my conclusion here, you're going to see what's well, I worked not very well, and what's my plan for the future if I ever have to work on this thing again. So to me, the ensemble architecture worked very well. Both the tabular one and the large language model one worked very well in combination. I was able to define, establish, and run a very good and scalable pipeline. And I was able to use the large language model ensemble to generate, very good uh, to generate brand names for a very good number of companies. So I think I failed one only on five or six companies that I was not able to generate a name. Now, as the session of what didn't work that well is the quality on the brand names. Sometimes we have competitor leakage and we have some repetitive pattern, meaning I'm using the same word two, three times in the brand name. For example, grand, brand. I used the word grand twice, and that's not great. I had to fall back on almost 5% of the time. If I ever have to work again on this type of work, I will try to apply this tabular DDPM, um, which is something interesting. I didn't dig deep into it, but I read that it can be interesting for, especially to add more variance to my data set. Would I know that before starting my work? I would start by using this guy on day one. Um, would as well train the large language model or fine tune the large language model and train it on negative examples. And maybe if it's a commercial product, I will use RAG augmented to augment the capacity of the large language model. In any case, the architecture I will use attention vase and maybe a hierarchical pipeline. Thank you very much for reviewing my work. Again, I have the references in all the bibliography here, the appendix mentioning the other repositories, and some additional code, and that's it. Thank you very much.